Hello and welcome. In this course, we just want to talk about the main steps that we can use to connect metaheuristics to the mathematical model. So we have some steps, and these steps should be taken to connect any optimization problems to any approach, and this approach would be metaheuristics. So we don't mention here that we have to just focus on GA or PSO or something like that. This kind of metaheuristic can be everything. So this is just general rule and framework, and we can use for any metaheuristic algorithm. So we have 5 steps, and the first one is just create a model, and we have to generate and save and call model. As you know that for any problem, for any optimization problem, we have some parameters. So we have to generate a model that will use this parameter. For example, if we just wanted to solve TSP, traveling salesman problem, one of these parameters is the cities, and another problem would be distance between any pair of cities. So these parameters should be created and saved, and this would be done in the first step. For the second step, we have to create random solution. Sometimes it's called crude solution, and in this step we have to grasp some information from the first step. So we define our model here, and we use some sort of information from our model to create a random solution. You know, we have a different kind of objective functions, so this create random solution would be different from problem to other problem. Suppose that we have a TSP, and sometimes we have a vehicle routing problem. So these two types of problem may have a different kind of random solution procedure. So it is quite would be disconnected from problem to another problem. In the third steps of this procedure, we have to convert this random solution to the mathematical variables. Actually, we have some variables, and it would be integer or continuous or even binary variables. It is related to our objective function and our optimization problems. So we have to convert them to the mathematical variables. In the fourth step, we have to handle all sorts of constraint and objective function, and I think that this is a critical step, and it is so vital. So we have to analyze our constraints. There are many different kind of constraints. Some constraints can be incorporated to the chromosome, so we don't use operate penalty function approach, but for some other constraint we may apply penalty function approach. I think this is the main steps of this process. And then last step would be connect objective function to the method. So we have defined our objective function, and this objective function would be measure the cost function. So in this regard, we have to put this objective function as a cost function that we have defined in any of metaheuristic algorithm. So I think for any given objective function, for any given optimization problem, this step would be quite critical and important. And by taking just these steps, we can easily connect mathematical model to all sorts of metaheuristic algorithms. Thank you.